Welcome back. In this fourth in the series on the introductory to the nervous system, we are going to learn about neurotransmission. So now we have the setup. We know what a chemical synapse looks like. We know who all the players are. So let's put it to work. The first thing that has to happen is we have to have an action potential, and this is the generation of an electrical impulse which is going to travel down the axon. So we're going to learn how this happens, much detail, the physiology and the physiology discussions. But basically, we're going to have a stimulus, it'll reach its threshold, and then we will have this action potential impulse carried down. Now, in a nerve, we can use the word nerve impulse interchangeably. Technically, there's a difference between the two, but as far as I'm concerned, the words are interchangeably. Now, living in the land of Hollywood, we're used to making movies where they have the placard, and every time they want the actress to start acting, they sit there and they clap it, and you go, action. So every time I say action potential, I want you to clap your hands. And every time I clap your hands, I want you to say action potential, okay? And this is going to give you a kinesthetic memory in addition to your auditory memories and your visual memories, which strengthens your memory and helps you learn the material a lot more effectively. In addition, I will try to do some stupid hand gestures. I'm not sure how well they work in the very confined space. Normally, I'm walking all across a room doing it, making a fool of myself, but since we're on a video, I'm really limited to what I can do. So, should we get started? Okay, fantastic. Action potential. No, I didn't hear any claps. Action potential. That's right. Okay. So where is that action potential generated? Who remembers? Oh, have we quickly forgotten? It starts way, way up there in the axon hillock, right? Right next to the cell body. The axon hillock, then it's going to travel down the axon until it reaches the axon terminals, terminal boutons. All right. So should we start over again? Action potential starts in the axon hillock, travels down the axon till it reaches the axon terminals and specifically the terminal boutons. Okay, so I'm going to say the process a whole bunch of times, and then I'll do all the hand actions and I'll do the whole thing at the end. So I really want you to kind of pay attention, because hopefully we'll have repeated it so many times that you'll really know it well by the time we're done. All right. So I'm just going to do hand actions for this time, and you see if you can remember. Starts in the, travels down the, till it reaches the, specifically the, okay. So now we're in the terminal bouton. In the terminal bouton, when that nerve impulse reaches there. Do you like the way I didn't say that AP word so you didn't have to clap again? Yeah, I did that on purpose. So when it reaches that terminal bouton, that causes an influx of calcium. So the red squiggly line is showing the action potential reaching the terminal bouton, and that causes an influx of calcium. That influx of calcium will cause vesicles filled with neurotransmitters to undergo what's happening in number 3. That's right. They're moving all the way to the plasma membrane and undergoing exocytosis. And they are releasing their contents into, what's that little space called? The synaptic cleft. All right, should we do that part again? Start at the beginning, you said? All right, we'll start at the beginning. Action potential. Starts in the, travels down the, till it reaches the, specifically the end is the, where it causes an influx of, which makes, filled with, undergo, releasing the contents into the, all right, did you get all those words? Do I need to say it again? All right, I will. Action potential starts in the axon hillock, travels down the axon till it reaches the axon terminal, specifically the terminal bouton, where it causes an influx of calcium, which makes vesicles filled with neurotransmitters undergo exocytosis, releasing their contents into the synaptic cleft. Any questions about that? If you don't have it, don't go forward. Stop, rewind, listen to this part again. If you do have it, let's continue on, okay? So, this now shows the brown dots, which are the neurotransmitters sitting there in the synaptic cleft. And what they are doing is they were looking at the postsynaptic cell in the plasma membrane. There's a transmural protein, an integral protein, which is a receptor. So they are looking for their receptor on the postsynaptic cell. Okay. When they find their receptor, they bind to their receptor, and that's going to cause something to happen. In this particular picture in the bottom left, when that neurotransmitter binds to that receptor, that causes something to enter this second cell. Okay, so does everybody have that part? All right, remember this neuroresponse can be excitatory or inhibitory. Should we add this to the other one? So let's start with causing an influx of calcium, which causes vesicles filled with neurotransmitters to undergo exocytosis, releasing their contents into the synaptic cleft, where they are looking for their receptor on the postsynaptic cell. Okay. When they bind to the receptor, they cause whatever change is going to happen in that postsynaptic cell, and then the neurotransmitter is kicked out. Okay, that's what's being shown in picture number 6 there. And so whatever was happening in that receptor, in this case, that channel was open, that channel is closed immediately. So what happens to that neurotransmitter? Well, it might be broken down by enzymes right there in the synaptic cleft, so it can't do anything else. Or it may be taken back up into the presynaptic neuron through endocytosis, and now it's sitting in a vesicle again, waiting for another message to be released and do its job again. Or it may be reuptaken, repackaged, sitting in a vesicle, and along comes a lysosome with its digestive enzymes, and it destroys it in the presynaptic cell. So you notice 2 of these 3 options is destroying it. All right, well, odds are it's going to get destroyed, but just letting you know all the options going on there, okay? So, do you need to review it one more time? Yeah, I thought you might. So let's go ahead and just do the hand motions, and you fill out the words, and if you get stuck, go back and re-review it. Action potential starts in the, travels down the, till it reaches specifically the, which causes an influx of, which makes, filled with, undergo, releasing their contents into the, where they are looking for the, on the. All right, you got it. Kudos for all your work. All right, so let me just talk for a minute about examples of neurotransmitters. Okay, so don't be memorizing this list. Okay, when you need to know the name of a neurotransmitter, I will tell you you need to know the name of this neurotransmitter. But right now, I just want to introduce you to examples of neurotransmitters. The first one's acetylcholine. Okay, you're going to need to know this one after this test because we're going to go to skeletal muscle. And this is the neurotransmitter, which is involved in all skeletal muscle contraction. And what acetylcholine is acetic acid bound to a choline molecule. Don't need to know it for this test, okay? So just warning you, for your next test, you're going to have to know it, but you don't need to know it for this test. So, diseases or conditions that affect acetylcholine, myasthenia, botulism, that's what Botox is doing. It's blocking the effects of acetylcholine, and nicotine smoking increases the effects of acetylcholine. Don't need to know those details for this test. This is just the part of this heavier part of the lecture where, oh, this is much more interesting. Let me talk about this with my family, okay? There are some other amino acids, glutamate and its relative gamma aminobutyric acid, which is known as GABA. These are really important for creating new memory, and it's GABA that and glutamate that they're very susceptible to trauma, and they are affected in Alzheimer's disease. And that explains why people with Alzheimer's cannot remember what they had for breakfast that day, but they can tell you what they ate for their wedding 40 years before. They just can't create new memories. Other examples of neurotransmitters are some things which came from amino acids. Don't be memorizing these pictures, but they're words you may have heard of already. Epinephrine, norepinephrine, if you don't know those words, you've heard of adrenaline. Adrenaline is the same thing as epinephrine. Serotonin and dopamine. A lot of these work with your moods and memory and compulsions. And I love dopamine because this is the reward motivation one. This is the neurotransmitter that really encourages a keep on with it. Okay, you didn't get the grade you wanted on the last test. But that doesn't mean give up. That just means, okay, you need to refocus. Why am I taking this class? Set a new motivation and get some support system going. Okay. Then we have some that we call neuromodulators or neurotransmitters, but basically they're kind of changing messages coming in. Examples of this are nitric oxide, not laughing gas. This is nitrous oxide, but nitric oxide, which is a very potent dilator, which like the little blue pill that men take involves this. And endorphins, a lot of you have probably heard about endorphins. Endorphins are chemical messengers that, for instance, affect something called substance P, which has to do with pain perception. So it comes into play. The classic example where you would have endorphins kick in is at times of severe stress. So if, for instance, you would back up your car over your pet or your pet's foot or something, and like, so your pet can't get on, like you could sit there and you could lean and pick up the car, even though, like, you know, you're 98-pound weakling and you can't carry your groceries in the house, but now you're so stressed, you've got all these endorphins in your body, you can pick this up and then scoop your dog out or your cat out and take them to the vet. And then people go, well, how'd you do that? And you go, I don't know how I did that. Well, I'm just telling you, it was your endorphins kicked in. And then a very, very popular neurotransmitter is our friend caffeine. Okay. So if I were to ask you what caffeine does, you would say it's a stimulant, wouldn't you? Yeah, because it wakes us all up. So would you be very surprised to hear that it's actually an inhibitor? Yeah, it is. So here's why it stimulates you. It doesn't cause excitation, it causes inhibition. What it's doing is there is a synapse down the road which is inhibitory. And what caffeine does is it blocks those inhibitory messages. So it's blocking a blocker. And so by blocking the blocker, it's now allowing messages to go through, and that's why you wake up. Okay, now, if you need that much caffeine in a day, you have a major league problem, right? And so you need to rethink your caffeine consumption. All right, so with this lighter part, hopefully you don't think this is too oppressive, but I'm going to tell you before you watch the next section, go back, make sure you know this section code, do the stupid hand gestures. If you have to, repeat it, write it all down, make sure you have it. And I will see you again for the final small episode. Have a great study session, and I will see you shortly.